So like I said previously, functions are very, very important because they can be used to model different scenarios in real life. So for instance, profits, costs, revenues are all modeled with functions. So functions are going to be very useful to us. As a matter of fact, we will do a lot of mathematics this semester involving functions. And in order to tell that something is a function real quick, we actually develop a special kind of notation. This notation basically is the following notation: y equals to f of x. Now, what is this notation and why does it look the way it does? So first of all, the letter x inside the parentheses is typically called the independent variable. And it doesn't have to be the letter x. It could be t or w or whatever letter it wants to be. But the letter inside the parentheses is supposed to represent the quantity of things you're making if you're running a business, for example. So it's how many things you're building or selling or whatever. The letter on the outside, which in this case I'm calling the letter f, is also interchangeable sometimes with the letter y. So sometimes people write f or y. Typically speaking, we write y by itself or f parentheses x, all like that. That letter is typically called the dependent variable. So again, the f doesn't have to be an f. It could be capital P for profit, capital C for costs, capital R for revenue, and whatever, depending on the context that you're working with. So whenever you see the notation f parentheses x, or for example, r parentheses t, you should know that whatever follows is going to be some sort of a function. So whatever we write over here, if you were to graph it, you will notice that the graph is representing a function. Now, one of the tests that we have to do is evaluate functions. So how do you evaluate a function? And how do you know that somebody's wanting you to evaluate a function? So first of all, to know that somebody wants you to evaluate a function, all you have to do is look at the notation. It says f and then parentheses and -1 instead of the letter x. So what does that mean? That means they want you to go to the function f of x, which in this case is x squared, plus 5x minus 6, and replace all the x's with -1. So notice how I did it. I read the expression, but instead of writing the letter x, I actually wrote parentheses. And so I read it x to the power of 2 plus 5 times x minus 6. I didn't actually write down the letter x, but then I looked over and I saw it, well, they wanted a -1 in there, so I just, at the end, put in a -1. And so at this point, all you have to do is compute the numbers. So in this case, we get 1 minus 5 minus 6. And the total there is going to be -10. By the way, -10 is called the output of this function. So when the input is -1, the output is -10. And a convenient way to represent this input-output business is to write down the ordered pair. The ordered pair would look like -1, -10. So in other terms, this -1, -10 pair tells me that when -1 is inputted into the function, I will see a -10 on the output. And this is important because no matter whether I'm doing it today or you're doing it or another friend is doing it, we all get the same output when we put the same input. And that's why functions are super special. They always result in the same output for the same input. So for example, if I'm looking at the second one, it says f of 1, and I tell you to do it, you should get the same result that I'm gonna get. And let's test it out. So and how do I do it? So first of all, I'm seeing the letter f on the outside, so that means they want me to go to the function f. And again, that one is x squared plus 5x minus 6. However, this time they want me to plug in the input 1 and then compute the output. So in this case, 1 squared is 1 plus 5 minus 6. And the answer is going to be, at the end, just simply 0. So the input in this particular case was 1 and the output was 0. And whether I do it or you do it, we will both get the same input and output. Now, how about f of x plus h? So this one's a little bit tricky. So let's do it kind of carefully. So it says f of, instead of the letter x, it has x plus h. So again, the way it's going to work is like this. Don't overthink it and don't overanalyze it. Don't let it be too difficult. First of all, we're seeing the letter f on the outside. So that means they want me to use the function f of x in this case. So the function that's called f. And again, what you want to do is write down the function, but without writing the letters. So write down x squared. So instead of writing the letter x, just put parentheses, squared, plus 5 times x. Again, don't write down the letter x, just put parentheses there, where the x would have been, and then minus 6. Then look at what the input was. In this case, the input was x plus h. And go ahead and fill in the parentheses with x plus h. So that way the inside of the parentheses matches the input of the function in this case. Okay? And at this point, all you have to do is FOIL everything out, combine like terms, and you'll basically be finished. So you can try to do this one on a scratch paper. If you do it, you get x squared plus 2xh plus h squared when you multiply it out. Then you multiply 5x, and then 5 with h, and finally the negative 6. And just very quickly, are there any similar terms that can be added or subtracted? The answer is no, so that's the end. That's the solution. In the next part, they want me to do f of x plus h minus the f of x. So in this case, they want us to do f of x plus h, which is the result that we just obtained from the previous part, minus the f of x itself. So in other terms, they want me to replace this whole thing, f of x plus h, with the solution that we ended up with on the previous line. All of these guys go first. And then they want me to subtract the f of x itself. So let's go ahead and do that. So we have x squared plus 2xh plus h squared plus the 5x plus 5h minus 6. All of these guys represent just the stuff that happened before the minus sign. So this represents the first part of the problem. Then we have to subtract because that's what they want to do. That's what they said pretty much in the middle. They said subtract, and then the f of x itself. Now be careful, because you're subtracting, you will need some parentheses around the function f of x. So it's not just enough to just write down the function x squared plus 5x minus 6 like this. If you did that, you would be committing a mistake, because the minus would only go to the x squared, but it's supposed to go to all of the function f of x. So this is the reason why we need parentheses. And so again, those three over here represent the function f of x. So what I'm going to do next is clear out the parentheses. And so in order to do that, all I have to do is give the minus to these three terms at the end. So at this point, once I've given the minus to the x squared, the 5x, and the negative 6, they switch signs, and I'm going to combine like terms if there are any. So for instance, in this problem, x squared at the beginning and negative x squared are going to cancel out because they're similar, but one of them is positive, one of them is negative. The same thing is going to happen again with the 5x and the negative 5x. They will cancel out. And then again with the negative 6 and the positive 6. They will also cancel out. So what I'm left with is 2xh plus the h squared plus the 5h. And none of these have the same letter with the same exponent. So none of them is a like term. So that's the end of the problem. That's the solution. Now in the next part, they want me to take the f of x plus h minus f of x and divide it all by h. This, by the way, is called the difference quotient. So this fraction that we're doing right here is going to be very important later on in the semester. It will be actually the way we define the derivative. So it's got the difference quotient. That's what we call this whole expression. And this difference quotient has f of x plus h minus f of x. By the way, we did that result on the previous part, so all I have to do is just copy it over and then divide everything by the h. And in order to do this, I can use what we did in the previous few pages about division. So I'm gonna notice that there's only one term in the denominator. So what I'm going to do now is break each one of these into its own little fraction, and then just divide each fraction one by one. And when I do that, the h's on the first fraction cancel itself out, and we end up with 2x. The h's on the second fraction also cancel out, and we just get 1 and h. So that one is just going to be h over 1, which is h. Then finally, the h's at the end cancel each other out, and 5 times 1 over 1 is going to be 5. So that's the solution because none of the terms can be added or subtracted. And again, this is what we call the difference quotient. And that's important because it will be the way we define a derivative.